Now we are going to learn about scalar and vector quantities, children. What is a scalar quantity? A quantity which has only magnitude but no direction. A quantity which has only magnitude but no direction is called as a scalar quantity, children. So, if you take mass, what is the mass of an object? Any object. Let us take that it is 5 kgs. Okay, let us take the mass of an object to be 5 kgs. So, do you say that it is 5 kgs to the west, 5 kgs to the north, or 5 kgs downward, 5 kgs upward? No, you do not say like that. So, mass does not have a direction, children. Similarly, distance. Distance also, children. Distance also does not have a direction. How far is your house from the school? 10 kilometers. Let us take, for example, 10 kilometers. Now, this 10 kilometers is the distance from your house to the school. Are you saying, teacher, 10 kilometers to the north, teacher, 10 kilometers to the south, teacher, 10 kilometers west, teacher, 10 kilometers east, teacher? No. The distance is just 10 kilometers. So, this also does not have a direction. Now, length. What is the length of this laptop? Maybe around 20 centimeters. Yes. So 20 centimeters, that's it. You do not tell any direction for the length. Similarly, pressure also does not have any direction, children, which means it acts in all directions. Suppose you are applying pressure at one point. It does not move only in one particular direction. It moves in all directions, children. That is what you need to remember. It does not have a particular direction. Wherever you apply pressure, it acts in all directions. That is why we say that pressure is a scalar quantity. Next, vector quantity. A quantity which has both magnitude and direction. Both magnitude and direction. Examples are displacement and force. Displacement has a direction, children. What is meant by displacement? The shortest distance from one place to the other place. Now, suppose I ask you, what is the shortest distance from your house? Teacher, you have to go this way, teacher, and then come back to the school. You have to show the direction if you're telling me the shortest distance. If I'm asking you, where is your house? You can tell me, teacher, my house is in Enmalukuduru. But if I say, what is the shortest distance to the school? Then you have to show me which way I need to come. Is that clear, children? Similarly, force also. When we are talking about force also, we are saying that a force is being applied on this direction and it is 5 newtons. And another force is applied and it is in this direction. That is why we say in net force, if both the forces are along the same direction, then we add them. Is it not? Net force. We add if they are along the same direction. We find the difference if they are in opposite directions. Is that clear, children? So that's all we have to learn in this chapter. Let us recall what we have learned in this chapter. The first thing is force. A push or pull on an object is called force, and the unit is Newton. When we perform so many activities, children, we saw that in some cases the force was able to move the object. In some cases, the force was not able to move the object. And we also learned that the force is an external agent. So we said an external agent which changes or tries to change the state of an object is called force. The next thing is effects of force. What are the effects of force, children? Force can change the shape of an object. It can change the size of an object. It can increase or decrease the speed of an object. It can change the direction of an object. It can bring an object at rest to motion. It can bring an object at motion to rest. We have also learned that rest means zero motion. Okay, children. Now the next thing is net force. What is net force, children? Net force is the resultant of all forces which are acting on a body. And if the forces are along the same direction, if F1 and F2 are along the same direction, then F net is equal to F1 plus F2. If they are in opposite directions, then F net is the difference of these. Is the difference of these two. And it moves along the direction of the larger force. And now if the forces are equal and opposite in direction, then the net force is 0, which means when F1 is along this direction, F2 is along this direction, but F1 is equal to F2, then in that case F net is equal to F1 minus F2. Now the next one, children. Types of forces. We have two types of forces. One is the contact force and the non-contact force. The contact force has again been divided into two types. One is the muscular force and the second one is the frictional force. The muscular force is the force exerted by the muscles, and frictional force, it is usually an opposing force, children. You will be learning about frictional force in detail later in the next classes. So frictional force is an opposing force and it acts between the two surfaces which are in contact with each other. We have learnt many examples also. Now coming to the non-contact force, this is again divided into three types. One is the magnetic force. The force between any two magnetic materials or a magnet and a non-magnetic material and a magnetic material. Force between two magnets or magnetic materials is called magnetic force. Okay, magnets or magnetic materials. Now electrostatic force, the force by a charged body on charged or uncharged body. The force which is acted upon by a charged body on a charged body or an uncharged body. We saw many examples for this also. And the last one is the gravitational force. Gravitational force is the force between any two objects which have mass. Any two objects which have mass. That is the gravitational force. And the next one is pressure. What did we learn about pressure, children? Force acting per unit area. What did we learn about pressure, children? It is the force acting per unit area. And the unit is Pascal. Pressure can be written as force by area. Does it have any direction, children? Just now we learned that it does not have any direction. It acts in all directions. Therefore, it is a scalar quantity. And then we have learned that solids exert pressure. We have taken many examples. We have taken the example of the elephant, and we also have taken the foot of the lady who has been wearing high heels. And then we learned liquids exert pressure at the bottom and on the walls of the container. We have performed activities for this. And then we have learned liquids exert pressure at equal heights. We have also learned activities for this, taking a bottle, attach a glass tube, put a rubber band. If you go through the previous videos, you will be able to remember. And we have also learned that pressure increases as depth increases. I gave you the example of the taps in the apartment as well, and decreases as the altitude increases. Children, we know that as the height increases, pressure decreases. As the altitude increases, pressure decreases. In atmospheric pressure, we said, okay, we'll come back to it in the next topic. Atmospheric pressure. The pressure exerted by air is the atmospheric pressure. And we also said that it is measured with the help of a barometer, and so it is also called as barometric pressure. And this also acts in all directions, and the atmospheric pressure decreases with the increase in altitude. Children, we said that the envelope of air which is surrounding the earth is called as atmosphere. And now as we go above the atmosphere, the air decreases. Is it not? As we go above, air decreases. You will not have too much of air as we go above. So what happens, children? As a result, the atmospheric pressure decreases. So we conclude that with the increase in altitude, there is a decrease in pressure. With the increase in altitude, there is decrease in pressure. Or with the decrease in altitude, there is an increase in pressure. And the last topic which we have learnt is scalar quantities and vector quantities. Scalar quantity, a quantity which has only magnitude but no direction. Vector quantity, which has both magnitude and direction. Is that clear, children? I believe that you have understood the entire chapter. Go through the videos once again if you have any doubts, and please copy the notes which is given. We shall perform activities also regarding this